What I want to talk about today is sampling. We've already talked about what sampling is. We already know that you've got to sample at twice the maximum frequency in the signal to avoid aliasing. And in the time domain, we've already talked about what that looks like. You've got a cosine, and if you undersample it, this is what happens when fs equals fmax. If you undersample it, aliasing makes your signal look much lower frequency than it actually is. And we also said that in the continuous time domain, a frequency that is equal to fs over 2 corresponds in the discrete domain to an omega that's equal to pi. The highest frequency you can have in the continuous time domain after sampling at fs corresponds to the highest frequency you can have in the discrete time domain, which is omega radians per sample. And another way of saying that, if we multiply both these sides by 2, is that a continuous time frequency of fs corresponds to an omega equals 2 pi radians per second. And that's just a fancy way of coming up with the f to fs is like omega over 2 pi relationship that we've talked about earlier. If this is the dTFT, don't forget you can bring that into the DFT world by saying k over n. But today I want to give you a broader perspective of how digital signal processing systems actually work. The prototypic system back in the dark ages is we had this analog world, and we would take that in, we would use sensors to measure the analog world in terms of voltages, and then you'd have blocks of analog circuitry, which is really EE122, 223, that converted it to something else, and then we put the result back through some kind of controllers. Maybe it would be LEDs, maybe it'd be a voltage meter, maybe it'd be motors, and that would return us back to the analog world. What goes into that block, what goes into this block is knowledge of signals and systems, EE230, knowledge of controls, and other classes. The problem is that it's hard to design. Do you remember the MATLAB programs we used in signals and systems for EE230? And then we'd have to take that filter design program that I wrote, that analog filter design program, and you had to put it over into another simulator like LT Spice to simulate it. And then you had to build your device. And so it's also hard to build. And I can almost guarantee that the first time you tried to build your circuit, it didn't work, and you spent a lot of time debugging it. And then if you wanted to change it, you'd have to go through the process all over again. It was not just a code change.